What a beautiful question. Right, I'm going to enlarge this so we can read properly. It says, a tennis ball is dropped from a height of 100 centimeters, bounce and rebounds to 80% of its previous height. The height is 8 centimeters of the ball after n bounces is given by this formula. So the height is where it starts from times A, which is a ratio, and n is the number of bounces, where A is the height from the ball and A is the percentage of the height reached by the ball in the previous bounce. So everything for you is given. I'm going to take this pretty picture away and move it up so we can actually then do the question. Okay. So let's move it this way, make this a little bit bigger so you can read. Our formula looked like this. It said H equals A times A to the power n. They say find the values of A, and hence write the formula for H in terms of n. Now they said that A is the starting height, which means therefore for A that big A is the starting height, and that's 100 centimeters. Small a is the percentage. Now we never put a percentage there, we always put a decimal. So if I say 80%, 80% means it's 80 out of 100, and that is 0.8 as a ratio. Therefore, H equals 100 times A is 0.8 to the power n. Is this what they ask? Write the formula for H in terms of n, which means n is the only thing that changed. Okay, so that's 1A. Let's look at B. What height will the ball reach after 5 bounces? So if n equals 5, what happens? Well, H equals, we want to know what's H if n is 5. So I'm just going to substitute 5 in my formula. So H equals 100 times 0.8 to the power n, which is 5. Okay, unless you are as smart as I am, you can't do that in your head, and you use a calculator. That's why I'm smart, and that will be 100 times 0.8 to the power of 5, and my answer is 32.768. Just make sure the question says to 1 decimal place, so that will be 32 point, that 7 will become an 8, so it will be 32.8 centimeters. So after 5 centimeters, that will be there. Okay, let's look at the C question. I'm going to move C here. It says, how many bounces will it take before the ball reaches less than 1 centimeter? Okay, so what they ask us is again, for less than 1 centimeter. So let's see how we get to, so we want n when h is 1. So let's just use h as 1. So when h is 1 centimeter, right, A equals 1 equals A, and what is A? Sorry, it's 1 equals 100 times 0.8 to the power n. I'm going to swap these two sides. So I'm going to say this. I'm going to divide by 100 on both sides. So I'm going to say 0.8 to the power n equals, and I'm going to divide by 100. 1 over 100. Okay, this is the same as 0.8 to the power n equals 0.01. Now, I'm going to take log both sides. Okay, so I'm going to say log 0.8 to the power n equals the log of 0.01. The n is going to go to the front, and I'm going to divide by log of 0.8. Log 0.01 divided by log 0.8. That is log, not logo. So let's have a quick look. Clear? I'm going to say, can you see that? I can. That is log of 0.01 divided by log of 0.08. Nope. Let's delete 0.8. Enter. My answer is 20.63 bounces. Remember, N is bounces. Now, if you leave me that answer, I will say well done, and you'll lose half a mark, and you will also lose communication marks. The reason is, what is 20.63 bounces? Bounces can only be integers. It can only be whole numbers. So, after 20.63 bounces, I will reach 1 centimeter, which means at 20 bounces, I will go higher than 1. So they ask us, when will we reach less than 1? And therefore, we will say, therefore, when n equals 21 bounces, not because that is 0.63. This could have been 0.01. Do you have to round up? Because it will only reach 1 centimeter after 20 point something bounces, and therefore 21 bounces.